Are there any questions you guys have on anything that you've looked at, or any kind of general questions on how we're set up? Uh, I'm assuming how things are working here will kind of change and evolve as we find things that work for us better, um, or just tools that are more efficient. So as we figure that out, we'll adapt. If there are any things or anything that you can think of that would be helpful, please again do let me know. We're trying to figure this out in a way that's going to be as helpful for all of you as possible. So um, yeah, your feedback can be helpful in trying to make all that happen.
When I was doing the homework,
Mhm.
I've never been on this side of it, but my open math, it would be cool if they had a little blurb about why the answer is what it is and why it's not the ones that it isn't,
Yeah, my math lab used to do a little bit of that. It would
Yeah.
have like it's a rounding issue. This one doesn't, but one of the things I would encourage you to do, have you, the My Open Math is right now on your screen? Yes?
Nope.
Nope. Oh, is it now?
Oh, there's this thing. Oh, there it is. Yeah.
Okay. So one of the things that I would encourage all of you guys to use when you're in a homework problem,
Uh-huh.
it'll eventually, I want to make sure I get this wrong. So as soon as you get it wrong, it's got a link. It should have a link. Where's the link to send your instructor a message? Oh, I'm not seeing that because I'm not in student view, I think. See if that changes it.
Oh, there's Reed. I didn't see that.
Yeah, that will take you to the particular section. There's some of those that save a video that link you to a couple of just some of the videos, which is handy.
Oh, cool. Okay.
But there should be a link here. There's not. I'll have to fix that. I think it's for the question, Kim. Now I know that it's not there. But there will be a link once I fix it that says, send your instructor a question.
Okay.
So if you're unsure why something's wrong, you can send that off, because it can be hard to figure out sometimes, because sometimes it's just a little rounding issue.
Right.
And it's hard to know that, or versus something more structural. So yeah,
Huh.
that can be a little frustrating. But always feel free to send me an email about it, or a message in My Open Math about it. Even if you can't use the ask the instructor button, you can always go to the message and just tell me what problem it is. I can look at it.
Okay.
Sometimes it can be hard to figure out what exactly that problem was.
Uh-huh.
There was, particularly if it's a weird rounding issue, but it is, but we can usually figure it out if we can talk about it.
Okay.
One of the things that can help with rounding issues is that there is a assignment I can put up here if it's helpful, about how the system wants you to be putting in answers, some of the default rounding conventions. I think My Open Math defaults to 3 decimals of accuracy. So if you're not otherwise told, it'll expect you to answer to the, what does that make that? The thousandths place, unless it otherwise tells you.
Okay.
So that can be a good assumption to be working under. One of the things I did put up yesterday was I put up the discussion boards for us. The first thing you guys should do for those discussion boards is go through and introduce yourselves. So like, I introduced myself. I'm Matt. I was a math major and I'm worried about all this. But we try to be helpful, or hopeful anyway. But there are some people who've started to introduce themselves. I do want to make sure that you guys go through and, well, one, do that introduction, but also be looking at these discussions each week. So you do have a discussion. I believe they're set as being due on Mondays, but we'll be ideally discussing the stuff that we're working on this particular week. So putting those discussions in there early is going to be good. I thought a fair amount about what to do with the discussion topics, but I really just settled on, if you want to see a description, it's down at the bottom of this page. But they're really just, what things did you have a hard time with this particular week? What questions were, weird? What vocabulary are you not quite sure about? So we can kind of start discussing those and help each other with those. Not only do these discussions give you a chance to talk to each other about issues, I go on that discussion board and answer questions and make comments, but also just reading through those, if you guys are talking about what you're struggling with, then I can pick out things and go, okay, that's something we have to talk about. This is something I want to add some clarity to. So the more that you guys can use those discussions, the more you'll get out of the discussion board, and hopefully the class in general. Some people really like discussion boards. Some people don't. Either way, it's okay. I've when doing classes myself that had discussion boards, I've not always been a big fan. But there's a lot of research and a lot of studies that show that being active in discussion boards, particularly for online courses, but for any courses, can have a big effect on success rates. So being engaged, being active on the discussion board can end up making a big difference, particularly with everything going on. So do make sure you're being active in that. I will put this in to encourage that. I will put this in part of your homework grade. You're officially expected to put one post every week and one reply every week. But I do hope that that won't become an issue, won't be something we're having to kind of be counting and looking for, because you guys are going to be using this tool robustly. Never worry about posting something extra. If you, near the beginning of the week, have a problem that you're struggling with and you post it, and you're like, oh, but now I can't post this other problem. Post the other problem. The more we have going on here, the more everybody will get out of it. Any questions about the boards? We'll play with them more as we go along. And actually, one of the nice things about this format is I can pretty easily bring them up in class and open one up, and we can talk about it and play with it. So that should be helpful. You do have that homework assignment due on Friday. Most of them are due Mondays, but just this first week, one is on Friday for homework 1. It's fairly short. It's mostly little questions on the vocabulary, some of which we talked about yesterday, the rest of which we'll talk about today, about types of data, but the rest of it's about the whole, population and sample versus statistics and parameter stuff. But also, Kim, as you mentioned, there are videos in here. If you're struggling with any of these problems, keep in mind you can go to some of the videos that talk over some of the material. So that could be a nice source of extra help as well.
Cool.
Any questions about the MyOpenMath stuff? Any of it giving anybody any trouble?
Nope.
Okay. Oop. That went back to the big picture of me, didn't it? I don't like the big picture of me. There we go. Gotta fix those. Okay. So before we start talking about types of data, is there anything you guys need or want? I know there's only a couple of you here today, but all the better for getting specific things answered. Nick and Grace, you guys are good? Awesome. So yesterday we talked about parameters versus statistics. The big difference being a parameter was a value based on the entire population, where a statistic was a value based or result based on the sample. In general, we will be using statistics to attempt to approximate or get information about a parameter. When we talk about the data that we're going to be looking at. We do have a couple of different types of data, and that's what I want to talk about today. We'll use the word variable a lot in terms of the data that we're going to be collecting. We use the word variable a little bit differently here than we do in the algebra courses. In general, a variable in your algebra courses is numeric. And usually in most of your algebra courses, it is the variable standing for some real number. But in here, our variable is whatever it is we happen to be collecting data about. That could be a number, or it can be other things. So examples we talked about yesterday were in terms of what number of credit hours people are taking. So that would be a nice numerical value. Some of our other examples yesterday were things like colors. What's somebody's favorite color? That would be not a set of numbers. But it's still values of our variable. Our variable in that case would be favorite colors. So it doesn't have to be a value when we're talking about variables. But we will, in general, describe the thing that our data is measuring or counting or noting down, the things our variables represent as our data. When we talk about our variables, talk about our data, it does come in two types. The main two types that we'll talk about is qualitative data. Sometimes we call qualitative data categorical. Those two things mean the same thing. These qualitative or categorical variables allow us to classify individuals based on some sort of category, some sort of characteristic, some sort of attribute. So it might be something like color. It might be something like male versus female. It might be what team somebody plays on. It might be where you went for vacation. Something that is a non-numeric, generally, category or quality. Even things that are subjective, like best, better, good, fine, fair, some sort of subjective label for something. It's qualitative because it's talking about a quality. And we refer to it as categories because we are putting our data in different categorical boxes. It's just those boxes don't necessarily have numbers associated with them. We'll talk about the issues with numbers a little bit in a second. Its counter set, the other type, is our quantitative variables. Quantitative variables are our meaningful numerical values. Things like numbers of credit hours, people's heights, shoe size, number of people that voted for a particular issue, anything that's got a meaningful numeric value. When we talk about meaningful numerical value, it's essentially a value that the raw number has a particular numerical meaning, meaning we can add it, we can subtract it, we can do arithmetic operations and get a meaningful result. A nice counterexample is if you're on a sports team, the players are all assigned numbers, usually on their jerseys. That jersey number, it doesn't have a value-based significance. Now, that doesn't mean it doesn't encode information. For example, if you're playing football and your jersey number is 60s, 70s, I think 50s, 60s, and 70s, that means you're usually a lineman. You're not allowed to receive a pass, but you are able to line up on the line of scrimmage. So that number has meaning, but the value, the specific value, isn't meaningful. If you take a jersey number of 78 and add it to a jersey number of 10, that 80 doesn't mean anything. If you average two team members' jersey numbers, that result isn't meaningful. So even if those numbers encode information, if that information isn't a value, then they're not quantitative variables. So just because they're numbers doesn't mean they're meaningful numbers.
Mm.
That makes sense?
Yeah,
So we do
that's
have to be a little
helpful.
careful. Even things like shoe size, excuse me, is an interesting one. Shoe size, they don't necessarily, like if you have a shoe size of 7, that 7, is that 7 inches? Is it 7 meters? Is it 7 millimeters? Just because that 7 doesn't have a, a nice accepted unit on it, it still does have a numerical significance. If you take, say, my shoe size of 12 and my daughter's shoe size of 7, add those together, get 19 divided by 2. So what's that? 9.5. So our average shoe size is 9.5. That 9.5 might not be useful, but that 9.5 is a reasonable number. If you say 9.5 is the average shoe size of our house, that would be okay. That makes sense. I don't know why somebody would care, but that number makes sense. So it's still a meaningful numerical value. So there's often some, you can debate between where different types of variables land. Sometimes there's a lot of gray area, and we'll talk about some of that. Some examples here of variables. We've got a researcher who was studying the effects of eating habits of adults in their mid-30s. It's got some information there about source. But this study had many variables that they were trying to take into account as they studied their patients. And for each of these 5 variables, nationality, number of children, household income, and so on, I want you to take a minute and try to decide which ones of these variables you would consider qualitative or categorical, and which ones of these variables you would consider quantitative. I'm going to give you a minute or two to do that. So let's talk through these. I know there's only a couple of us here today, but I would like you to type into the chat what you think. So for nationality, you think nationality is a categorical or a quantitative variable? Let's see who's active here. Qualitative, categorical, qualitative. Nice. Now, qualitative and categorical, again, we can kind of use interchangeable. I'll tend to use categorical as opposed to qualitative, mostly just because qualitative and quantitative can be hard to tell the difference between when you say them. And honestly, words that start with Q are tough enough for me as it is. So I'll often use categorical as opposed to qualitative, but they're both, they both mean the same thing. So yeah, qualitative. Okay. Nationality is a nice, solid, it's hard to argue about nationality being anything other than categorical. It is a label we put on something. It's not something we count. It's not something we measure. It's a label, so it's qualitative or categorical. Good. What about numbers of children? Categorical or quantitative? looks like one quantitative and one categorical.
Mhm.
Quantitative. Quantitative. Kim, you were saying categorical? Why categorical?
Well, because you wouldn't, I don't know, maybe you would add the numbers of children, like to find the average of number of children in a household. Would that be quantitative?
Yeah. So say I had, 5 children, somebody else had 2 children. If we add those together, we get 7 children, and 7 children is a legitimate amount of
Okay,
children.
so that would be
Yeah. And if we divided it by
quantitative.
2, we'd have the average number of children we both have.
Yeah,
So,
okay, that makes sense.
and it is something that we count. We count up how
Yeah.
many children we have. Um, so, yeah,
Okay.
number of children does tend to sit in a pretty solidly
Quantitative.
quantitative, pretty solid numerical data set.
Okay.
Now, that doesn't mean we couldn't assign categories, like say if somebody has, 1 child, or like say you have a box for people who have 1 to 2 children, a box for people that have 3 to 5, and a box that have more than 5. You could assign categories.
Okay.
Make it categorical if you wanted to, but the strict question number of children, the expected response would be a value.
Quantitative.
Yep.
Okay, makes sense.
Household income
Well, that's
in a particular year.
quantitative. How do you spell it? Quantitative. Oop. Quantitative.
So Grace, we have quantitative, Kim, quantitative, Nick, categorical. Is it Micah? Well, you got quantitative. So Nick, why categorical?
I was I was looking at it like level of income based on class, like middle class, upper class, lower class income.
Nice.
Oh,
I like that because these last couple have some arguments about them. Household income is a nice one. We think of household income as being, okay, that's a number. It is a very fixed number. But often when you're, filling out a form like this, or if they're doing a survey, oftentimes they don't ask what the income is. They'll ask, is your income in this range? Is it like say, less than 20,000, between 20 and 50, between 50 and 75,000, or 75,000 or more? So oftentimes when you're doing something like this, Nick's absolutely right. It's broken up into some sort of category. Or if they have a definition for, like, even it could be even, would you consider yourself middle class, upper class, below the poverty line, above the poverty line? So it could be categorized very easily. Now, on its face, if you just say the household income, that does certainly sound like it should be a number. You can add incomes together. You can average household incomes. So it certainly could be a quantitative data, and I think quantitative is probably the most natural answer. But we could certainly turn it into categorical quite easily. And for things like surveys or questionnaires like this might have, that would be pretty common. So that's
cool.
I like that mix of responses. What about level of education? You guys seem pretty solid into the categorical. And on its face, I wouldn't argue with categorical. Level of education, if somebody asked, what's your level of education? Answers would often be things like, some high school graduate, some college, associate's degree, master's degree, bachelor's degree, doctorate. So that certainly does have a categorical feel to it. Could we turn it into a quantitative set of data?
Mhm.
And if so, how would we do that? What kind of things could we?
Like if you did an average of, what's the average level of education of everybody in this course?
Right, but how would we measure that? How would we turn those?
Oh, so you take the year and add it together and divide it?
So turning education levels into years of education can be a very effective way to quantify, to turn it into a quantity. Things like level of education. We certainly look at education for kids in 1 through 12 pretty commonly, but even for post high school, for secondary or post secondary education, we often talk about years of education.
Mm-hmm.
So we certainly could have a household, say, that has somebody with a master's degree that's a 6-year degree, and somebody has an associate's degree that's 2 years. Adding that together, that family has a combined 8 years of post-secondary education. That's a meaningful value, and we could certainly average that.
Mm-hmm.
On the last class, somebody mentioned level of education. You could do it in credit hours. How many credits of post-secondary education somebody has?
Oh, yeah.
You can certainly add those together and certainly average that, or do any arithmetic operations on that data if you wanted to. So level of education certainly is probably, again, most naturally thought of as categorical, but you might think back to surveys you've filled out. Often they ask things like years of education. And that's, again, because they're trying to quantify it so they can do things like find useful numerical descriptions. So one of the things I'm hoping that you note in these is, particularly these last two, there's not necessarily a solid answer to it. There is what would be the most natural answer for it. Certainly household income, one would tend to say quantitative. Level of education, one would tend to say categorical or qualitative. But an argument can be made. And the most important thing for us to kind of get used to doing in problems like these is not just having an answer, but having a reason for that answer, being able to express or explain your justification for that answer. So like with Nick's answer of categorical for household income, it's a perfectly reasonable, perfectly correct answer, because Nick's justification used the definition of categorical to properly describe it as a categorical variable.
Mm-hmm.
So oftentimes, whether our answers are yes or no, or depends on what our justification for it is. So we want to get you used to thinking that way. Unfortunately, the MyOpenMath, any online computer, isn't necessarily great with making us do that. So we want to kind of force each other, as we talk to each other and as we work together, to be practicing that thinking about why are we thinking it's this way. Sometimes that thinking is wrong, and that's okay. That's why we're here learning. But oftentimes, depending on how we look at something, it can make a big difference. What about this last one? The daily intake of whole grains measured in grams per day. Is that qualitative or quantitative? Quantity. You guys are really quick on the quantity. I'd make anybody nervous? Am I going to tell you why it's actually categorical?
Oh.
Now, we could certainly make it categorical, daily intake of whole grains enough versus not enough. I just categorized it. But particularly that parenthetic that says measured in grams per day. As soon as it says the word measured, this is a number.
Okay.
It even tells us in grams per day. So, okay, I had, 11.7 grams of whole grains in that particular day. I don't even know if that's a lot. I should learn more about whole grains. But particularly that measured in gives us a lot of information about how this variable is defined. But if we defined it differently, did I eat a small amount, a large amount, more than my daily allowance, less than my daily allowance, we could certainly categorize this variable. But you guys are absolutely correct, especially with that. I would tend to think of daily intake of whole grains as quantitative anyway, but that measured in grams per day really locks it in.
Okay.
Questions about any of those ideas? I can't see any of you other guys either nodding or shaking your heads or looking confused.
It's
Kim, I
very
can see
helpful.
you, Kim, but everybody else is just being all shy. Nick is good.
Good.
Micah, the thumbs up is great. Love that. Okay. So not only do we have these main types of data, when we talk about quantitative variables or quantitative data, that's again our numerical value, it also breaks into two different types. And sometimes the difference between these types means we're going to have to be using different tools for them. So we want to make sure we kind of start getting a sense of this distinction between our types of numerical data or types of quantitative data. Just like though our types of data, we can often argue between, if you define it this way, it's one way. If you define it differently, it's another way. So it still has a lot of that kind of fuzziness to it. But understanding the distinctions, what they mean, and why we might make those choices is going to be important for us as we go along. So our two types of numerical data, our two types of quantitative data. The first one is discrete data. Discrete data is essentially something that we've counted. And when we talk about counting something, you imagine there are discrete pieces that are being counted. For example, I've got, a pile of coins here. There's, I think 10. Yeah, 10 coins. When you count coins, you count there's 1 coin, 2 coins, 3 coins. You're counting discrete, separate objects. And because of that, you're not going to have anything that goes between, say, that third coin and the fourth coin. There's not a 3.5 coin and a 3.6 coin and a 3.59 coin. They come in discrete bunches. So we generally associate discrete variables with the idea of counting. There are exceptions to that, but that's kind of a good way to think about it. One of the big exceptions is, again, I think I mentioned before, shoe size. You don't count really your shoe size. You have a little thing that you measure it on usually. But if, unless you're getting custom made shoes, generally shoe sizes are in discrete values, but there is something between a shoe size of 7 and a shoe size of 8. You can go get a 7.5, right? But is there anything between that 7 and the 7.5?
No.
There's a gap in between there. And discrete just essentially means you are in separated gaps or separated values. You don't have the opportunity to be anything in between those two values. You can't go into a store and say, I want a 7 and 13/91 shoe. They're going to look at you like you're crazy. Now, if you have a custom made shoe, you can have one measured to any level of accuracy of any particular size. But our general understanding of shoe size is a discrete variable because there are jumps between values. Does that make sense?
Mm-hmm. Yep.
As opposed to continuous variables, which we often think of in terms of measuring. When we think of a continuous variable has kind of a range of values in any particular interval. So for example, if I want to measure the length of this table, I wouldn't count really anything. I would have a tape measure or some sort of tool, and I would measure it, and I could get, say, 48 inches or 48 and a half inches. I could certainly get 48 and a quarter, 48 and a third. I could get any measurement within some sort of interval. They're not, table length isn't broken up into discrete pieces. It's not impossible to have any particular length. One of the tests for the distinction between continuous and discrete is if you have two values of, again, I'm going to go with the table length. If I have a table that is 48 inches and another table that's 48 and a half inches, is it possible that there's another table in between there?
Mm-hmm.
Certainly it's possible. That's because table length is distributed continuously. If I have a shoe that's a size 8 and a shoe that's a size 8.5, is there anything in between those?
No.
No, because it's discrete. Fair? If it's possible to have measurements with nothing in between them, we're a discrete variable. If there's always things in between, we are a continuous variable.
Okay.
So our variables, essentially we have three categories. We can break them into our categorical variables or qualitative variables, or our numeric data into quantitative, and that quantitative further divides into discrete and continuous. But just like our categorical versus quantitative, sometimes we'll take something that is discrete and kind of treat it like it's continuous, depending on how we define it, or take a continuous variable and treat it like it's discrete for whatever purpose we might have. A nice example of that, I think, is people's heights. If you ask, somebody how tall they are, you might get somebody who says they're, 5'11" versus somebody who's 5'10". Are there measurements for height in between 5'11" and 5'10"? Sure. How many? There are technically infinitely many heights between those two.
Mm-hmm.
But we don't tend to measure people's heights down to the millionths of an inch, right? We tend to think of, okay, we maybe go down to as far as half an inch increments. So we might think of height as in more of a discrete way. I'm not going to care about anything between, 5'10" and 5'10.5". You got to pick one of those. So it is a continuous variable, but sometimes we'll treat it like it's a discrete variable. Happens sometimes with other things as well that are technically discrete, but the amount of variation, the discreteness is so small. We'll talk about this more later. The discreteness is so small, we can kind of get away with pretending it's continuous. So we'll talk more about that as we go along, but there is some distinction in there. I want to go back to that example about the study of eating habits. It had three variables that we considered quantitative, or most naturally quantitative. Take a second and look at those three variables and decide for yourself which one of those is discrete versus which one of those is continuous. I'll give you a couple minutes to think about that, and then we'll talk. So what do you think about number of children? Is that discrete or continuous? Kim says discrete. Nick agrees, discrete. Mike discrete. Everybody discrete. Yeah, discrete is great for numbers of children. We certainly do count our children. Um, you can certainly have 1, 2, 3 children, but you don't tend to have 3.5 children or 3.25 children. One could certainly argue if, let's say, you're trying to list number of children on a tax form, and you've got some agreement where you're only claiming, half of a kid because of custody. So an argument could certainly be made, but in general, even if you've got shared custody of a kid, that's your whole kid, right? That kind of depends again on how we define it. For tax purposes, okay, maybe it would, cutting them up. I hate to use the phrase cutting them up. Dividing them up would be reasonable. But in general, we think of the number of children as solidly discrete. What about household income? Discrete or continuous? Got 3 continuouses. Nick, continuous. Household income's an interesting one. Now, one thing to be careful of, when we talk about, often people get a little hung up on this household income because it specifically says household income in the previous year. And I found what that often does is it makes people think that because that household income is from a previous year, that it is a fixed value. And because it's a fixed value, they want to say it's either discrete or continuous. But this, household income for a previous year, if you ask 1,000 people what their household income was on a previous year, you're going to get lots of different responses. And those different responses can fit under a wide range. Our question is whether that range can be any number within that range, or if it's going to fit in discrete bits. So the test, again, is to decide whether there is a small interval that there's nothing in between. So let's say a household income of $10,000. Okay, if one's household income of $10,000 and the other has an income of $20,000, there's certainly incomes in between there, no question. What if we make the distinction smaller? So one household is $10,000, the other is $10,001. Is there money between $10,000 and $10,001? Yes, of course there is. You can have a whole bunch of money in between $10,000 and $10,001. But if we make it small enough, if one person had $10,000 and 23 cents, and the house next door had $10,000 and 24 cents, is there anything between that 23 cents and that 24 cents?
Nope.
Anybody else want to weigh in? It's like, no, we don't want to weigh in, or no, there isn't a distinction. Or are we worried whatever you say, I'll turn it into something else? Now, for most of us, most people, particularly talking about households, that's usually most people, we deal with money in terms of whole cents. But of course, a lot of corporations do talk about, tenths of a penny and hundredths of a penny or even more. Heck, even gas stations, they try to trick us into thinking, it's less than $4 a gallon because it's $3.99 and 9/10 of a cent. Gas stations do that to us so they can round up. So it is certainly possible to break income down into tenths of pennies, hundreds of pennies, thousands of pennies if you wanted to. But technically speaking, since a tenth of a penny really doesn't have any value, technically speaking, household income is discrete.
Mm.
However, as I said, if that discreteness, if that distinction is sufficiently small, then we often deal with it like it's a continuous variable because that distinction is so small. Now, from the most part, money or like costs, we think of as quite discrete. If you look at, like, say, the cost of a candy bar, those are discrete values because, if one's $1.29, the other's $1.30, those are two discrete values. But in terms of household income, we're usually talking about, things like tens of thousands of dollars. The distinction between cents starts becoming somewhat immaterial. So it does kind of behave like a continuous variable, even though it's technically speaking not. So in a lot of ways, I like that you guys thought about that in continuous, because, between any two incomes, there's room for just about any other income you'd want to put in between there. Though technically we could go down to the penny and make an argument about it, it really does behave over an interval as opposed to big, discrete, separated chunks. So which one is it? I would tend to treat it as continuous in almost any application. So I like the answer continuous. But if we were going to be super, super picky,
Mhm.
we'd probably have to go discrete. But no, I like continuous as an answer there. What about daily intake of whole grains? Discrete or continuous? Everybody wants discrete. Anybody want to say why discrete?
Measured in grams.
Right, but which one did we associate with measure?
It's quantitative.
Right. But discrete,
And
we talked about counting.
right.
Continuous, we talked about measuring. Right?
Right.
So the use of the word measuring, now it doesn't necessarily mean it's one way or another, but the use of the word measure is generally a hint towards continuous.
Oh. Mm.
And if you want to measure how many grams of whole grains, what would you do? Would you count the grains, or would you, like, say, weigh it?
Weigh it.
You'd probably weigh it. Now, could you physically count them?
Oh.
With the right tools, you probably could, but that would be arduous. So the word measure would tend to move us more towards continuous than discrete.
Oh.
Anybody else want to say why they chose discrete? Either unmute yourself and tell us, or type it.
Would you have a tenth of a gram?
Sure.
Don't you measure grams, whole grams?
You could have a tenth of a gram.
Mm.
Tenth of a gram is fairly small, but whole grains are pretty small.
Okay.
We can have, and certainly we have things like kilograms and
Oh, yeah.
centigrams and milligrams, right?
Yep.
So,
Hmm.
Nick, Grace, or Micah, you want to weigh in on why discrete? Just thinking discrete because it says whole. That's interesting. I actually haven't had anybody
Whole grains.
say that before.
Oh.
That really is interesting. So
Yeah.
intake of whole grains. So whole grains is just a type of grain. So it's essentially a label. So you
Hmm.
can have whole grains in pieces, but it is interesting. We have to kind of know what we mean by whole grain as opposed to um, a um, a ground grain or other types of grains or a processed grain. It really does have to do with how it's processed. But without knowing that, the idea of a whole grain would start to argue that we count it and it would be discrete. That's really interesting. So yeah, that's just a vocabulary issue, but that's an interesting thought. I like that thought. Anybody else want to either change to continuous? It looks like Grace changed to continuous, or want to say why they thought discrete.
Makes sense.
So really, Kim's question about can we measure in tenths of a grams really comes down to the point. Can we measure a tenth of a gram of whole grains? Certainly we can. A
Yeah.
hundredth of a gram, a millionth of a gram, and nanograms and micrograms. We certainly do, and certainly can. Uh, so this would be considered a continuous variable. You can have any amounts of grams between 1 gram and 2 grams. There are infinitely many amounts of grams in between there. The really only way to argue discrete, if you want to compare it to the household income, we can go down to that single penny, and that penny won't break down anymore. One could make an argument that you could break it down to singular molecules of whole grains. So you could break it down into the molecular weight in grams of a single molecule of whole grains, and you wouldn't be able to break it up any past that. But that is not a either common or reasonable way that we measure whole grains by molecular weight. So because whole grains are measured over a continuum, over a continuous interval of weights, whole grains would be generally considered a continuous variable as opposed to a discrete. Questions about it on any of those? When you guys do say stuff, I like it. You guys say good stuff, but so quiet. All right. The other thing in chapter 1 that you will see has a section in there on levels of measurement. We won't do that. Levels of measurement it's an interesting concept. It's an interesting idea. Some of you who go, fairly deep into statistics or data collection will talk a bit about levels of measurement. But for the most part, those of you who are going into business and psychology or just general uses of statistics level, the level of measurement usually doesn't come up that much. And if it is in your discipline, you'll have specific courses that talk about it in a broader way. So, if you want to read through the section on levels of measurement, of course, do so. It is kind of interesting, but there's not any homework about it or any test questions or labs or anything about it. It's interesting, but not especially useful with what we're going to be doing. And it's a little weird, frankly, but it is neat. So if you're interested in neat things about measuring, you can actually go into, if you want to go into mathematics, the whole field of metric theory and measurement theory is actually really interesting. So really like it. There's a whole pathway you could go on to, but for us, we'll leave it there. So for the chapter 1 material, that's really the important bits I want you to pull out of that chapter 1 material. It really is mostly just vocabulary about data. Sorry, I want to pull this other thing up. Shouldn't have started talking. I do want to talk a little bit about chapter 2, well, the start of chapter 2 while I have you here. But before we do that, I'd like to make sure that you guys have any questions or comments or thoughts that have come up. I hate to keep asking that and have everybody metaphorically stare at it. But I should just wait. You guys can either say, yes, we're good, or I have a question.
All good.
So that's 1. Nick's good. Micah says we're all good. Are people telling Micah that we're good and not telling me? How about you, Grace? You good? All right. So we're going to be working with a lot of data in this course. So talking about organizing data some is going to be good. We're going to use a couple of organizational tools a lot. So making sure we have a good set of common vocabulary with each other about it is going to be helpful. So one of the most, I guess, useless things is to have just a big piece of paper that has just all your data, all your numbers scrawled all over it. It's really hard to organize. It's really hard to work with if it's just some big pile of particularly numbers. Big pile of numbers often doesn't do anybody any good. So looking at different ways to organize that, we're going to talk about in chapter 2. One of the first tools that we're going to use is what we're going to call a frequency distribution, often just referred to as a frequency table. We'll have probability distributions later on as well, but really probability distributions are just an example of a frequency distribution. In frequency distributions or frequency tables, we do list the categories of our data and how often they occur. This does use the word category of data here, but that doesn't necessarily mean it's a categorical variable. It can be a quantitative variable, and we'll see some examples of that as we go along. So probably the best thing to do is just jump in and look at an example of a frequency table. Often in class, I have a example and we count through it, but here I'll just, oops, let me bounce to that. Just look at the frequency table. So this is what a frequency table looks like. Usually you won't have that column with the tallies. I say that's there when we count it up together in class. But this has our categories of colors of M&Ms, brown, yellow, red, orange, blue, and green. So that's our, 6 categories. And the frequency table just tells us how often those particular categories occurred. So out of our big pile of M&Ms, 12 of them were brown, 9 of them were red, 3 of them were blue, and so on. The frequency tables, they tend to be fairly straightforward, but there are some issues we'll run into with them, and we'll talk about those as those issues come up. But they really just tell us, hey, this is what happened. How often did it happen? As I said, it can be, instead of categorical data here, it can be quantitative data. This could be things like, let's say we were measuring, I'm going to stick with number of credit hours. So say it was 12 credits and 13 credits and 14 credits, 15 credits, 16 credits, 17 credits. So these could be number of credit hours, and then the frequency of how many students had 12 credits, how many students had 13 credits, how many students had 14 credits, and so on. So this could be numerical data as well as categorical data. The frequency still tells us how often did that data point occur. In this particular example of these M&Ms, how many M&Ms did we have? Or how would we figure out how many M&Ms that we had?
Find the total
Find the total of,
number of M&Ms.
well, that's what I asked. Can we find the total?
Yeah, just add
Yes,
them up.
find the total, and Nick, absolutely, find the total of the frequencies.
Yeah.
So if we add the individual frequencies together, we'll get how many objects we had, how many events, to use the technical term, how many events occurred. So if you add those up, how many M&Ms were here?
22, 31, 37, and 8, 45. 45.
Looks like 45 to me too.
Yeah.
So we had 45 M&Ms. So this 12 is 12 out of that 45. This 9 is 9 out of that 45, and so on.
Mhm.
Oftentimes, that ratio is more informative, or at least just as informative, as the raw amounts of occurrence. So as well as frequency tables like this, and bounce up back up here again, we'll often instead look at relative frequency tables. Those relative frequency tables, instead of telling us the raw frequency, tells us the proportion of observations within a particular category. So, for example, the brown M&Ms happened 12 times. So those 12 brown M&Ms divided by the 45 total M&Ms will give us the proportion of M&Ms that were brown, their relative frequency. I'm going to jump back. I have one of those. So we often have, instead of frequency tables, relative frequency tables. Now I've just kind of put the relative frequency table on the end of the rest of this table, but oftentimes you'll just see those two outside columns, the colors and their relative frequency, and have a nice relative frequency table. So with this, we can see that not only did we have 12 brown M&Ms, but that 12 was 26.6% of our M&Ms. The orange was 13.3% of our M&Ms. So sometimes that proportion is more informative or more what we're interested in than the fact that we had 6 of them.
Mhm.
You know, if you're just worried how many you have, the frequency is great. If you're worried about, well, what does this say about, you know, M&Ms in general? Well, if you buy a random big pile of M&Ms, we might expect to have 13% of them be orange.
Mhm.
So depending on what we're interested in, frequency versus relative frequency, we'll use one tool over the other. Often we'll have both and use whichever one we're more interested in at the time. Oh, we lost Nick. So down there it says find the sum. What happens if you add up all of those relative frequencies? What do you get? Take a moment and decide what you get if you add all those up.
Mm.
Kim jumped right to 100%. Now, Kim, you're expressing that as a percentage, and there's certainly nothing wrong with expressing that as a percentage. 100
Or 1
percent
should add, yeah.
Yeah, 100% is 100 per 100, which is 1. If
Yeah.
we add up the proportions, we certainly would add up to that whole solid 1. And that is something that I want you to start getting used to. Um, we're used to thinking, and we often speak, and I will as well, often speak in terms of percentages, but those proportions, the decimal form of that, the 0.2667, we'll often be better off expressing that as the decimal proportion as opposed to expressing it as a percentage.
Okay.
If I'm going to tell somebody, kind of conversationally, how many orange M&Ms we had, 13.3% is very effective conversationally. But when
Mhm.
we start trying to put things into our formulas and start trying to do our mathematical mechanics on things, we will more often use the decimal form of the
Okay.
percentage, which we generally refer to as the proportion. So that 0.133 is the proportion. Again, I'm not going to say you're wrong if you express it as a percentage, but if you
Yeah.
put it in as 13.3 into most of our formulas, it won't work.
Okay.
So working towards getting real comfortable with dealing with the proportions instead of percentages can be real helpful. And that
Okay.
often takes a while because our language is so used to dealing with percentages. So for all of you, keep that in mind as we go along. But yeah, our relative frequencies should always add up to 1. And that ought to make sense. If you add up all of our proportions, all of our percentages, we should get the whole bowl of M&Ms. And particularly if you think about it in the fraction form, this 12 45ths plus 10 45ths plus 9 45ths plus 6, 3, and 5 45ths.
Mhm.
Well, if we add those up, we already know the 12, 10, 9, 6, 5, and 3 add up to 45.
Right.
So this will add up to 45 45ths. So kind of by the definition of relative frequency, this had better add up to 1. That's going to be a really helpful and important thing to keep in mind because often we will have the relative frequency for some of our information, but not all of it. So for example, if we didn't know the relative frequency for reds and didn't know the frequency for reds, and all we had were these other relative frequencies, we could certainly find the relative frequency for red because we know they have to add up to 1.
Mhm.
So add up all the others, subtract them from 1, and all of a sudden we know the value we want. So keeping in mind that relative frequencies, that our proportions, our probabilities in some cases should add up to 1 is going to be a common tool for us to need access to. So keeping that in mind from early on is going to be helpful. Let's see, it's 12:50. This class ends at 12:50, doesn't it? Hey, good, because I'm more or less done. There's a couple things I want to show you. We'll often talk about bar graphs. Bar graphs, usually you guys have a lot of familiarity with, so I don't expect bar graphs to be a problem. The big thing to keep in mind is most of our bar graphs in here will have that vertical axis be either frequency or relative frequency. Frequency is going to be an important idea in most of this class. So most of our bar graphs will have whatever our data is down on the horizontal, whatever variable we're measuring, and that vertical axis should be frequency. So try to keep that in mind. You can find these PowerPoints on my website through the math department. They can also be relative frequency. That will be pretty common. These two graphs are essentially the same, except that one's blue. But this is in terms of frequency. This one's in terms of relative frequency, expresses the same set of information. We'll talk more about pie charts a little bit later. You guys have seen pie charts, I imagine. We'll use pie charts a little bit, not a tremendous amount, but enough that we want to make sure we can read them. And we'll talk more about displays of data as we move into chapter 2.2 tomorrow. But any questions before I let you go today?
Nope.
Grace, if you have any trouble
Okay.
finding those PowerPoints, there are PowerPoints on my Open Math. They're the ones that the textbook puts out. They're a little bit different. I often take some things from there, but then kind of make my own. So if you have any trouble finding either of those PowerPoints, let me know. I can send you a link to that page. But if you go to the math department's website, to faculty and staff, and then under me, you'll find my website. Go to the 243 link, and then there's a PowerPoint link there. So if you have trouble finding that, it's a little bit of a chain, but if you have trouble finding that, let me know.
Okay.
Anything else I can do for anybody?
Mm.
Okay, everybody have a wonderful day. If anything does come up that you need, let me know.
Okay,
I'll see you tomorrow.
thanks. Bye.